Welcome to This Explainer. Today, we're diving into something that's literally flipping everything we know about agriculture completely on its head. Now, if you care at all about sustainable farming, crop yields, or honestly just the nutritional quality of the food sitting on your plate, you are definitely going to want to hear this.
So think about this for a second. We've spent decades trying to brute force our way to better farming, right? Dropping synthetic fertilizers and complex chemical cocktails from the top down. But what if the holy grail of modern farming isn't some brand new lab-made chemical at all? What if the ultimate solution is actually biological, microscopic, and incredibly ancient?
Right beneath our feet, just below the roots of our crops, there is this sprawling subterranean metropolis of microorganisms. But here's the thing, it's not just a random, chaotic soup of bugs in the dirt. There's a strict hierarchy, there's structure, and as you can see, there's a brilliant, hidden architect pulling the strings behind the scenes to make the whole ecosystem flourish. Here's our roadmap for today. We'll uncover the identity of Archaea, break down their control valve mechanism, look at the hard science, and see how this practically revolutionizes farm management. Finally, we'll hit the real-world farm results and the incredible synergy between medicine, food, and agriculture.
All right, kicking things off with part 1, the identity of Archaea, life's source.
You know, Archaea isn't just your run-of-the-mill bacteria. Actually, scratch that. It's not bacteria at all. It's officially classified as the third domain of life. It's a completely distinct branch on the evolutionary tree. We're talking about ultimate survivors from extreme environments, dating back 3.5 billion years. Because they evolved to thrive in literally boiling heat, super high salt, and strong acids, they're armed with what we call extremezymes. These are specialized enzymes that just do not quit under harsh conditions, acting as ridiculously powerful purification engines that break down organic matter at a foundational level.
Moving right along to section 2, the control valve mechanism manipulating soil.
This is where it gets really cool. For the longest time, agriculture has operated on this major misconception, just lumping all soil microbes into one big bucket. But they have entirely different jobs. Basically, bacteria act as the workers. They do the heavy lifting of fermentation and oxidation. But Archaea, they are the managers. And they don't just sit side by side with bacteria, they're metabolically linked. Archaea are the ones actively adjusting the environment so the bacterial workers can actually get their jobs done properly.
So how exactly does this microscopic middle management work? Well, Archaea exert indirect but absolute control through 4 distinct methods. First, they manage thermodynamic pressure. Second, they dominate the nitrogen cycle, keeping the bacteria completely in check. Third, they actually use physical attachment to directly influence how resources are allocated. And lastly, they act as lead architects, literally designing the spatial structures, the biofilms, where these microbial communities live.
The absolute most critical of those is the thermodynamic control. Archaea act literally as a metabolic control valve. See, when bacteria work, they burp out emissions, things like hydrogen, ammonia, and organic acids. If that stuff builds up, the bacteria essentially choke on their own waste, and the whole reaction just stops dead. Archaea consume those emissions, keeping the concentrations incredibly low. By doing this, they make sure the bacterial assembly line keeps running smoothly without ever bottlenecking.
Okay, part 3, the dramatic scientific basis for environmental improvement. Let's look at the dirt itself.
In conventional farming, things get out of whack pretty fast. Bacteria become unbalanced, metabolism stagnates, and precious nitrogen just off-gases right into the atmosphere. Total waste, right? But Archaea-optimized soil creates a perfectly efficient nitrogen cycle loop. By acting as those metabolic adjusters we just talked about, Archaea maximize nutrient retention right down at the root zone, exactly where the plant actually needs it.
And the numbers here are just wild. The Soil Health Index, or BF value, normally sits around a baseline of 3,000. With Archaea, it rockets up to an incredible 30,000. That is a tenfold leap in quality. Plus, because you've got this super robust, balanced microbial population, the soil naturally suppresses disease-causing fungi, dropping them by over 32%. You're basically building an invincible immune system for your crops.
Which brings us to section 4, implementation of farm regeneration, changing management. Let's talk business.
If you're running a farm, time is literally money. Normally, getting high-quality compost to mature takes anywhere from 3 to 12 long months. But by combining ArcNN with fine bubble technology, that timeline shrinks down to just 4 to 7 weeks. Think about what that does for a farm's inventory turnover, space requirements, and operational cash flow. It's an absolute game changer.
And then there's the logistics side of things. Instead of trucking literal tons of heavy, bulky fertilizer across the country, which we all know costs a fortune, a highly concentrated Archaea core liquid can be cultured right on site at the farm. This completely disrupts traditional supply chains. It slashes transport costs, cuts energy consumption way down, and gives farmers total independence over their own supply.
Let's see the proof in Section 5. Value proven by actual farms.
Let's head over to Awaji Island. They've been using this Archaea method on Koshi Hikari rice, and the root systems these plants developed were incredibly robust. Because the soil environment was so perfectly dialed in by the Archaea, these crops completely withstood recent extreme weather events. We're talking severe heat and wind damage that totally devastated neighboring conventional farms. So it secures your yield while actually reducing the backbreaking labor of constantly applying extra fertilizer.
And it's definitely not just rice. Okinawa root vegetables grown this way are showing 2 to 6 times the normal antioxidant power, grown entirely without pesticides. We're also seeing disease-resistant premium fruits, grapes with an incredible aroma, peaches with incredibly dense sweet flesh, and cherries that actually refuse to drop even during heavy storms. The visual and structural quality of this food is deeply tied to that underground microbial harmony.
Now, let's talk about something you've probably tasted, that bitter, harsh bite in some greens. That's caused by high nitrate nitrogen, which also carries real health risks. The EU's safety limit is around 3,500 milligrams per kilogram. Archaea farming dramatically plummets those levels. For example, in Kyoto-grown spinach, it drops down to a super safe 1,200 milligrams. So not only is the food vastly safer, but eliminating that harshness means the flavor profile is incredibly pure and sweet. Finally, Section 6, towards a future of medicine, food, agriculture synergy.
This all ties together in a really beautiful way. Healing the soil through Archaea naturally purifies the crops, reducing those harmful nitrates and skyrocketing the antioxidants. And when we eat those crops, we are essentially borrowing that ancient reducing power of Archaea to protect our own human cells from oxidation and aging. It creates this seamless, perfect loop of health that starts microscopic in the earth and ends right in our own bodies.
If you want visual proof of this antioxidation power, look at this. This is anti-culpa water, which mixes natural basalt water from Mountain Fuji with the extreme enzymes of Archaea. They dropped an iron paper clip in there, left it submerged for 8 straight weeks, and there is absolutely zero sign of rust. None. It maintains a super low oxidation reduction potential, which is the exact same power these microbes use to regenerate the soil and protect the plant roots.
By partnering up with these invisible managers, we are doing so much more than just bumping up next season's crop yield. We literally hold the key to a sustainable, radically abundant agricultural future. These mechanisms have been perfected over 3.5 billion years. We've just finally figured out how to tap into them. So, the only question left is, are we ready to step back and let the Earth's oldest life forms manage the future of our food? Thanks for joining me on this explainer. I really hope it leaves you looking at the dirt beneath your feet in a completely different light.